Hello everyone, I am Priyadarshini and we are the students of University of Windsor pursuing Masters in Applied Computing. This presentation is for the Web Search Engine project of the Advanced Computing Concepts course. The instructor of this course is Dr. Al-Qadeep. This web search engine is developed using Java language on the Eclipse IDE. Here is the brief outline of the presentation. Initially, we are going to discuss the team roles, continuing with the introduction, uses, and examples of a search engine. Then, we are going to explain about the features present in our project, and we are going to explain each feature in detail along with flow diagram, followed by the working demo of our project and the future scope. Finally, we will conclude by giving a brief summary in the end. Here are our team members and their respective contributions. We have individually worked on a feature. In our team, we have Angel, myself, Vaishnavi, Surya, and Rahul. Angel worked on the web crawler and HTML to text feature. I was responsible for the pattern searching feature. Vaishnavi worked on word frequency and auto suggestion. Surya was responsible for the spell checker, and Rahul worked on the page sorting part. Let's get started with the introduction. A web search engine is a tool that gets input as keywords or phrases from the user and gives output from the internet. The search engine checks the page URL, page titles, all the contents and keywords it has indexed, then does a step by step procedure to generate a list of most relevant websites. Let's see a few examples and uses. The most popular web search engine is Google. Other search engines include Ask.com, Bing, DuckDuckGo, and Yahoo. A search engine has many uses since any information can be retrieved from the internet using a single keyword. It is used by everyone on a daily basis. Let's just see the features involved in our project. Initially, we have used the web crawler and HTML to text, pattern searching, word frequency, auto suggestion, spell checker, and finally, page sorting. Over to Vaishnavi to explain about the web crawler feature.
Thanks, Priya. Hello, everybody. This is Vaishnavi here, and today I'm going to take you through the features of web crawler and HTML to text. So, first, talking about a web crawler, it's basically a computer program that crawls or searches for web pages for the keywords that are entered in the search engine. So, this technique is used by almost all the web search engines that we use, such as Google, Yahoo, and Bing. The keywords are indexed and are stored in a hash map. The information about the page is gathered and they are stored in the index so that they can be sorted later to fetch and rank for the users. Web crawlers keep track of the URLs which have been indexed or visited to avoid revisiting them. The URLs information, such as web page content, links on the web pages, destination to the links, and web page title, are collected. Moving on to HTML to text feature. So in our project, we have used JSOUP to parse the HTML to text files. So what is JSOUP? JSOUP is a parser framework that is used to parse HTML files, URLs, and strings. HTML files that are got by crawling the web page cannot be interpreted easily because they have tags and other details. So we have made use of jsoup.parse to parse and manipulate the HTML file. The converted text files are stored in a separate location, and when the user enters the search keyword, it is indexed from this text file. The reason for using JSOUP in our project is that it provides very simple API to fetch and extract the URL. So that's it from my end. Now handing over to Rahul for indexing and ranking feature.
Thank you, Vaishnavi. Now, the next step of this process is indexing. The act of adding information about a web page to a search engine's index is called indexing. This index is a database made up of several web pages which contains information about the pages that were crawled. The index catalogs and organizes the detailed data on the nature of the content and topical relevance of each web page, a map of all the pages that each page links to, the hyperlinks or text of any links, and other details regarding links such as whether they are ads or not, whether they appear on the page or not, and other features of the links context and much more. So when a user submits a query into a search engine, that is, so giving a search word into a search engine, the index is the database where the results are fetched from. So here, when the search word is entered by the user, the frequency of that word is calculated for each page for the entered word using try. And in order to understand what the page is about, search engines analyze the words that appear on it and then build a map of that data, which is known as a semantic map, which basically a relationship between the concepts of a web page. So each page with the frequencies are then added to a hash map. So this hash map acts as a kind of a indexing database. Now, to serve up results to the search engine's user, in addition to crawling and indexing, ranking must be done. This ranking returns web pages which are indexed in order of relevance and importance. So, as a part of the ranking process, the search engine needs to be able to understand the nature of the content of each web page it crawls. So now the hash map is sorted using collection sorts method, which performs better for larger amount of data, and these sorted results are then displayed to the user. Thus, this principle of crawling, indexing, and ranking helps website to tune them to make it easy for search engines to read and understand them and to better target them to the right search results. Thank you. Now Surya will continue.
The next feature which we have implemented is spell check. We have used the dictionary of most common words which are used in the English vocabulary and stored it in the form of an array. Once the user searches for the keyword, if the keyword is not found or if it is misspelled, then the similar words which are found according to the keyword based on the edit distance algorithm are provided to the user. This feature enables the user to search for the proper keyword with the correct spelling. The next feature which we have implemented is auto suggestion. The auto suggestion feature provides keyword suggestions to the user. Once the user searches for the keyword, each and every keyword is taken as a prefix word. So all other words which are found similar to the prefix word are fetched from the try. These matched words are provided to the user. By implementing this feature, we provided an open-ended search experience to the user. Talking about the overall flow about the project, at first, the user is prompted to enter the URL. If the user did not provide any URL, then the default URL is used for crawling. Once the URL is crawled, the HTML pages are extracted and then converted to text files using JSON. Next, the user is prompted to enter the search keyword. This keyword is validated based upon two conditions. If the keyword is empty or it has more than one word, then the error message is displayed and the user is prompted to enter the search keyword again. Once the user provides a valid keyword, an inverted index is created using hash map and this keyword is checked for spelling errors. If the keyword has any spelling errors, then the correct spelling of the keyword along with few suggestions are provided to the user based upon the edit distance algorithm. If not, if the user given keyword is a valid word with the correct spelling, then with the regex, we match all the patterns of the keyword and then get the frequency of the word in each text files. Next, we sort these text files based upon the list sort and provide these text files along with the keyword's frequency in each file and provide the results to the user. If the user wishes to search for other keyword, then they are prompted to enter the keyword again. If not, the program is terminated. Now, over to Angel for the demo.
Thank you, Surya. First, let me take you through the project setup in the Eclipse IDE. This is our project named Search Engine. We have referenced the system libraries as well as the JSON libraries. Under the source folder, we have the various Java classes written for the web search engine. The search engine class is the root class of the engine. The crawler.java class performs the web crawling function using JSON. The HTML to text class passes the HTML pages and converts them to text files. The converted text files are placed in a folder called as text files. The Searcher.java class takes care of the indexing and the page ranking module. The Spellchecker class implements the edit distance algorithm to give the word corrections. The Autosuggestions class uses the prefix match method of the TST class and retrieves all the words that match the prefix word. Constants like the crawling depth and the default URL are declared in the constants.java class. Now, without any further ado, let me execute the search engine. Let me run the search engine.java class. We have got the welcome message. The user can either enter an URL to crawl, or the user can continue with the default Wikipedia URL. I'm going to press enter and continue with Wikipedia. It says the crawling is done. I'm going to refresh the text files folder and check if the files are present. So yes, the HTML pages has been successfully converted to text files. Now we are good to begin our search. I'm going to search for the keyword network. The engine has returned me 12 results in about 82 milliseconds. And all the pages that contain the word network are listed here, and they are sorted. For instance, the page which contains the maximum occurrence of the word is ranked at the top, and the page which has the minimum occurrence of the word is ranked at the bottom. There are few auto suggestions as well at the bottom. For the word network, we have got network, networking, and networks. I'm going to press Y and continue. Let me search for one of the auto suggested word, say networking. I've got one result. I'm going to quit the search engine, and this is the exit message we get. Let me run the search engine.java class again. This time, I'm going to crawl the URL amazon.com. The crawling is done. Let me search for the keyword global. So I've got 15 results here, and the pages are sorted. There is one auto suggestion that is globally. Let me press Y and continue. Now, if I give the word hello, I get the result as cannot find this word in the files because the word hello is not present in any of the text files. Let me continue. What if I misspelled a word? Let me give the word search with the wrong spelling. So the engine correctly prompts, did you mean search or start? So this shows that the spell checker feature is working correctly. I'm going to continue. What happens if I search for two words? So, since the engine is currently designed to take in only a single word, we have got the result as you cannot search more than one word at once. What if I don't give any search word and press enter? So the engine says search cannot be empty. So let me again search for the keyword global, and here I've got the results as earlier. Finally, I'm going to quit the search engine. So it is evident from this demo that all the features of the web search engine are working perfectly. Hope you enjoyed this demo. Adding a user interface, including many URLs to perform an extensive search over the web, highlighting the search keywords in context, and enhancing the auto suggestion features are some of the future scope of this web search engine. The Advanced Computing Concepts course provided us with both theoretical and practical knowledge of advanced data structures and algorithms. This web search engine was developed applying all the concepts learned in the class. For our project, we referenced the class materials given by our professor Dr. Alkadeep. We thank him for all the guidance and support he had given us. We have come to the end of the presentation. Do write to us if you have any queries or feedback. Hope you liked the presentation. Thank you for your time.